something sometimes using because it's short. But Army is like way more concise.
Okay, here we go on the chapter 2 test review. Number 1. Hopefully you looked over your papers. You got any questions before we begin? Anything you want to bring up right now?
Hey, are you gonna go over the review? Just items on the test.
What?
Are we gonna go over the review? You gave us just items on the
The same thing.
test. Well, then we'll get to all my questions.
Okay. I guess I'll just dig in and tell you what I feel like you better watch out for. Okay? Because we haven't got that much time. We've got exactly an hour. These are the directions on every test. Show all steps leading to your answers, including any intermediate results obtained using a graphing utility. Use the back of the test or another sheet of paper if necessary. There is no back of the test, so another sheet would be great. The reason why there's no back is because the back is filled up with problems. Number 1 says,
I need the following students to go to the auditorium: Cade Taylor, Cicely Clay, Chad Gimenez, CJ Burden, Lizzie Baldwin, and Carly Williams. Thank you.
here's what it says. Use the graph to estimate the limits and value of the function, or explain why the limits do not exist. You cannot just say they do not exist. You have to explain why, if that happens to. So if we have something like this, okay, you got something like that, then it might ask you these kinds of questions. What is the limit as x approaches 2 from the left? Okay. What is the limit as x approaches 2 from the right? What is the limit as x approaches 2?
Does not exist.
Why? That's what you will write. Why what?
The limits approaching from both sides.
If you say they're not the same, I will not give you credit.
Why not? Going towards the same y value.
Because the limit as x approaches 2 from the right of f of x does not equal the limit as x approaches 2 from the left of f of x. There's your evidence. That's your explanation for the third part. All right? And they may also ask you, what is f of 1? Not 1. 2. 2. Do you all understand how we got these answers and how to explain the ones that don't exist? Moving on. Number 2 says, determine the limit by substitution. Again, people miss this because they fail to pay attention to signs, S-I-G-Ns. Something like this. You can see why signs would be trouble for you. Might be going a little too far afield here. Something like this. They ask you to find the limit as x approaches negative 2 of 3 minus 4x minus 2x squared. Can you see why signs could be a problem? If you do it by direct substitution, it'll be 3 minus 4 times negative 2. The entire x gets replaced with negative 2. Minus 2 times negative 2 squared. And when you handle order of operations properly, this is going to be a positive 4, but this product will be negative 8. So keep track of yours. This is positive 8. That's it. Be careful with signs. Here's one. This is where people mostly stumble. If I did that instead, how would that change it? It'll change it right there. This is still the substitution for x. It's still going to be squared, but there's still a negative besides it. Yeah. watch it on your signs. It's a direct substitution. You think it's easy, take care of your signs. Number 3. All right, in number 3, they're going to give you 2 facts. And then they're going to ask you to apply a property to figure out a combination of them of some kind. So let's say something like this. The limit as x approaches a of f of x equals 6. And the limit as x approaches a of g of x is -2. So what would be the limit, for example, this is just an example, what would be the limit as x approaches a of f of x times g of x? -12. Just like that. If this had been a minus, you would say it is 8. If this was a plus, you would say it is 4. See, it's just that easy. That's, yeah. And if it was division, it would be -3 if it were f over g. For g over f, it would be -1/3. Yeah? It's just that easy. All right. So number 3 is pretty straightforward. Number 4 says find the limit graphically. Show how the sandwich theorem can be used to confirm your answer. Number 4's answer looks like this. I don't know if you can see that very clearly, but number 4, it's got 3 blanks. See it? If you cannot fit the sandwich, if you cannot sandwich the sandwich theorem in that space, then you use these spaces to say, see scratch paper, or see bottom of page, or something. Show me where I can find it, because you may not be able to fit all your argument in there. The first blank is reserved for what your calculator tells you the limit is, because that's the first thing that's asked. It says, find the limit graphically. Show how the sandwich theorem can be used to confirm your answer. So you're going to get an idea from your grapher. You put that in the first blank, and then you use the sandwich theorem to prove it. So consider something like this. And this you probably will want to write on your review, because I don't have an example for you on the review. That's why I left a gap, left a space on the review paper for number 4. It might be something like this. What's the limit as x approaches 0 of -4 plus x to the 4th cosine of 1 over x squared? So you grab your calculator and try to figure out what that limit is. While you're doing that, I'm going to start putting together the sandwich theorem so we don't run out of time in here. So much glare on the board. Doesn't help much. Okay, so this would be how the sandwich theorem went. Did you get -4 for limit? So that goes in the first blank. And then the other blanks or some reference to some other location will have this information. You start out with a fact about trig, cosine and sine in particular. Whatever you cosine or sine is always trapped between -1 and 1. And you don't have to explain this, but this is where you start. Then, this is what's sitting in between the -1 and 1. So now you multiply every piece of your inequality by x to the 4th to get you to here. That's this next step. -1 times x to the 4th is negative x to the 4th. Then negative x to the 4th times cosine 1 over x squared and x to the 4th on the right. Everything gets multiplied by x to the 4th. Then you got to add -4 to every side. Adding -4 here to negative x squared is really the subtraction. What?
How did you decide to do the cosine of 1 over x squared? The first one.
I just made it up. Realizing the sine and cosine are always trapped in between -1 and 1.
It doesn't matter what's inside that. It's always negative.
It'll be either sine or cosine of something. So you start trapping those in between -1 because you know that's always true.
And then you take the limits of either side of the inequality.
Yes, you take the limit of this side by direct substitution, you see that limit's -4. You take the limit of this side by direct substitution, that limit is -4. Therefore, the limit of the thing that's trapped in between it as 0 must also be -4 by the sandwich theorem.
Okay.
Does that make sense to you?
So you basically just get the cosine thing.
Between
By
-1
itself,
and 1. And then you build the function all the way out. Then when it's all built out so that this thing in the middle is exactly what you're trying to take the limit of, then you take the limit of either end.
Okay.
And it better be the same number, because if it is, and it will be, it's the same number, then that means that the junk in between it at 0 is also that number. It has to be.
Okay.
Because both of the thing it's sandwiched between is the same value, so it must fit right in between at that point by the sandwich theorem. Everybody clear?
It's a tangent.
Get it down. Everybody okay on that one? All right. Number 5. Number 5 says for f of x, it's a rational function involving an absolute value. Does that mean anything to you? A rational function means what? No, that's an irrational. What's a rational function look like?
The fractions.
That may be what it looks like graphically. What does it look like as a function?
Oh, like that?
Fraction.
Like a fraction.
Yeah, it's a fraction. And so the function itself is a fraction involving x, and it also involves an absolute value. It might be the absolute value of the whole thing, or it might be the absolute value of the numerator, or the absolute value of the denominator. But it involves those kinds of things. And whenever you throw an absolute value into the mix, especially if you're talking about absolute valuing polynomials rather than lines, it's hard to tell what it looks like. So listen to the instructions. For f of x equals this absolute value involved rational function, use graphs and tables to find the limit of f at infinity, the limit of f at negative infinity, and then identify any horizontal asymptotes. You understand that's what you're looking for in A and B? Yeah, well, yes, if they settle on a number, if the end behavior is a number. Okay, so if it settles on something, let's say that as it went to the right, it took off, came up like this, and it settled down on something, let's say it settled on 3. And as it went to the left, it went down and came up like this and settled on -1. What are your horizontal asymptotes? No, not just 3 and -1. Y equals 3 and y equals -1. Yes.
The instruction on that said find.
Said find the limit as find the limit as x goes to infinity of f. Find the limit as x goes to negative infinity of f, and identify any horizontal asymptotes.
So you'd say.
Aren't you identifying horizontal asymptotes when you find the two limits?
You're trying to find them. When you say identify them, you identify them with an equation. Y equals what they settled on.
So when we're looking for like an asymptotic end behavior, for finding what they go to as infinity, right? The limit of f of x as x approaches infinity.
Yeah, and you use graphs and tables to try to figure that out. I would use tables to see what y is settling on. And then y equals those numbers. It's the same number, you only have to write one. It's possible that they approach the same thing from either side. Do you have any idea what I'm saying? You clear or not? You sure? Alrighty. So find the limits to the left, to the right, and identify horizontal asymptotes that are very, very closely related. Make sure you express horizontal asymptotes as an equation. Don't just give me a number. Ready to go on? Number 6 says, consider the function f of x given below, and it's not given to you as an equation, it's given to you as a graph. Asymptotes are clearly marked with horizontal or with dotted lines. I'll tell you this, there's a vertical one and a horizontal one. And the graph is kind of bizarre, but it's not hard, it's just kind of weird looking. It says, consider this function which is shown below. Which of the following appear to be true about f of x? So you can go on appearances only. And there are 4 Roman numerals, 4 facts that are given, and you have to decide if those facts are true or false. And so your choices, as you see on the review, are things like, it's a multiple choice one, and that might be 1 and 3 is true, 3 and 4 is true, 1, 2, and 3 is true, 1, 3, and 4 are true, or they're all true. So you have to look at the statements, look at the graph, and see if the statement appears to be true. And if it is, circle it or something, so that when it comes time to collect all those that are true, you can choose the right A, B, C, D, or E. That's about all I can tell you about that one. Okay? It's whether you can read a limit and understand what it means graphically. Is what they're testing. Okay. We're making pretty good time here. You ready to go on to number 7? You understand what you're doing on number 6? Study the graph carefully and look at every single statement. Decide the ones that are true. Number 7 has 2 parts. A part says, find the vertical asymptotes of the graph, and it's a rational function. Polynomial on top, polynomial on the bottom. Find the vertical asymptotes of the graph. That's the A part. How will you express your answer for A? X equals, and as many vertical asymptotes as it has. Okay. B says, describe the behavior of F to the left and to the right of each vertical asymptote. Describe the behavior of F to the left and the right of each vertical asymptote. How do you suppose the best way to describe behaviors at asymptotes is? With a limit. That's exactly right, with a limit. Use the limit notation to describe these. So, here's an example. I'll give you 2 examples, because I'm not going to tell you which type's going to show up. You have to decide. So if I have 5 minus x over x squared minus 25, and then that's f. Where will the vertical asymptotes be? How do you go about finding vertical asymptotes? Where the denominator is equal to 0? And nothing cancels. Something cancels here. Simplifying this expression is x minus 5x plus 5. This cancels, accounting for a -1 with this, which means the only vertical asymptote is x equals -5 in this case. You follow? If I change just one thing, now there are 2. So I'm not going to tell you which one to expect. There's one at -5 and 5. So this is what you would put in the first blank if it were this problem instead. Otherwise, when they cancel, it would only be expressing this one. There's a hole there. If it were 5. But it's not. If it's like this, that's what happens. Then you got 2 vertical asymptotes. And if it was like this, even if it wasn't, if it was only 1, you're still going to describe the behavior the same way. So you would say in the rest of it, the B part says, describe the behavior of F to the left and the right of each vertical asymptote. So in this case right here, you're going to have to say this. the limit as x approaches -5 from the left of f of x equals. And you'll have to say the limit as x approaches -5 from the right of f of x equals. And you'll have to do another limit from the left of the other one. From the left equals. And the limit as x approaches 5 from the right of f of x equals. And these will all be various forms of infinity. Positive or negative. You should graph it and see, so that you understand what you are going to be looking at and how you interpret it. So graph that rational function. Make sure you're using parentheses appropriately.
It's missing a lot of stuff.
What's that?
Missing a lot of stuff.
Missing a lot of stuff? Yeah, it is. Okay, let me see this for a second.
You can tell which way to start.
Yeah, you can tell which way it's going to go. So this is what the graph looks like for those of you who, your graph should look like that. You can see the asymptotes, although there's no vertical lines drawn. So let's focus on -5 for a minute. What's going on to the left of it? If you are to the left of it and moving along that graph towards -5, are you going up or down? If you are moving right towards -5, from the left side of -5, are you going up or down? Up. You're on the graph to the left of -5. You're over here. And you're approaching -5 to the right. Is that what you said? Did you understand that? Are you okay with that? Yeah. Okay. What's happening as you approach -5 from the right side of the graph? Going down. What's happening as you're approaching +5 from the left? Is that going up? And this one's going down. Okay? So, this is what you will write in the A blank. You don't need to write VA if you don't want. You can just write these equations. This is what you will put in part B if there's room, so make it tight. I mean, if it ends up being 4 different expressions, if it's pretty easy to fit. It'll be pretty easy to fit if there's only 2 in the case where one of them canceled. If there's 4, cram it in there if you can. Or send me someplace to look for it. Y'all understand what you have to do on number 7? Not too bad. Number 8. It says, for the function y equals, and it's a pretty involved exponential function involving e. It also involves a couple of polynomial expressions. Kind of ugly. Can't really tell what it's going to look like. It says, for this function, y equals this stuff involving x and exponential and so polynomial stuff. It says, find a simple basic function right end behavior model, and a simple basic function left end behavior model. So if you have something like this, and get rid of this. Pay attention here, folks. A right end behavior model means which of these terms, and there will only be one of them, which of these terms does this graph look like most as you go farther and farther and farther right? In other words, which one of these terms is going to dominate the growth as you go to the right? 3x cubed. That's clearly going to outrun this, right? This is going to keep getting tinier and tinier and tinier because that's 2 over e to the x. And if x is positive, it's 2 over something getting bigger and bigger and bigger and bigger. So this is actually approaching 0. This thing's getting huge. This will be your right end behavior model in this case. Does that make sense to you, the rationale? Okay. What's a good left end behavior model? What'll happen to this one if you go way, way, way to the left?
It's way, way, way.
Zero.
It'll get very small because it's gonna be 3 times something negative cubed is gonna remain negative. So it's gonna get a bigger and bigger negative number. Does that make sense?
So that's still big. Is that still bigger than does that outrun?
Let's see. It'll obviously outrun this, right?
Yeah.
What will this do as a negative x gets bigger, well, goes farther and farther left? This will be a positive number.
So it gets smaller.
Times -2 will be a negative number, a rather large one. Is this one larger than this one? Yeah, because this is almost 3 raised to a power, whereas this is just a number raised to the 3rd. That's different than when your power is growing. You understand this will outrun it?
Yeah.
Okay. So you have to, but make sure you're considering the fact that when you go left, this is actually a positive exponent. Pay attention to that when deciding. But the answer to both of those questions is going to be one of those terms in each case.
So the.
Not the same term, but one of them, one of those terms. What?
So the -2 equals -6 is what it's going by, so it outruns that.
3 times a negative number to the 3rd, and the negative number is getting larger in size. That's negative. So what's your question?
I got it.
Okay. But if this is a negative number getting bigger negatively, this is going to be a bigger positive number. This will outrun this. Because when your exponent grows, as opposed to what you're exponenting, this grows faster. Okay? All right, so that's number 8. You don't have to prove it. You just got to come up with one. Here's a way you can do it. If you decide you think you know what it is, you can graph this function and the function you suspect is it, and see if they're approaching the same y value as x gets really far right or left. You can see that in your table. When you go to table, it'll show you 2 y values if you have 2 functions in there. Okay, next one. We ready to go on? Number 9 says, find the points of discontinuity of this function. It's a rational function made up of 2 polynomials. So find the points of discontinuity, and for each discontinuity, identify the type. And it even gives you your choices: removable, jump, infinite, or oscillating. And I'll tell you right now, it won't be oscillating. So it's going to be removable, jump, or infinite. Your calculator will not show you the removable ones. It won't show you the whole. You have to come up with those on your own. It will show you the jump ones if there are. Okay? So it'll also show you the infinite ones. So the function is rational, involving 2 polynomials, something like this. How do you begin deciding where the discontinuities are? Factor. Good idea. How does the top one factor?
X minus 4x minus 2. And x minus 4x plus 3. Wow. Where you go?
So now,
Cancels out.
these cancel, meaning what?
Removable discontinuity of 4.
Yeah.
Removable discontinuity at x equals 4.
My bad. And there's an infinite discontinuity at x equals -3.
Perfect.
Oh, yeah.
That's what I
Because
said.
this will create an asymptote,
Right.
whereas this one will create a hole. This is an infinite discontinuity.
Take
Because it didn't cancel. This is a hole,
Yeah.
because it did cancel. There's still a problem before, but it's not something we can't fix. Do you all understand? So you would say something like this. This is how you would answer both questions at the same time. It asks you to identify the discontinuities and what type. So you would say, removable, discontinuity at x equals 4. Infinite, discontinuity at x equals -3. That would answer both questions. It tells me where they occur and what kind they are. All based on this evidence right here, if you know how to read. It's not that hard. Can you handle it? Now, if this had been a plus sign right here instead, how would that change things?
It would be plus the side.
Would be plus here and plus here, and so you would have an infinite discontinuity at 4 and -3. If that happens. You see what I'm saying? Okay, moving along.
If it's infinite discontinuity 2 could we put infinite discontinuity at x equals -3, 4?
Sure.
Are we ever gonna learn about the oscillator discontinuity in this class?
Not in this class. You will when you start studying infinite series. That'll be in Calc 2.
Cool.
He just wanted you to be aware of them. He never actually talks about them much himself, the author of this in this book. All right, here we go. We okay on number 9? How to handle it and how to answer the question? Cool. Next says, number 10 says, find A. And oh no, it doesn't. It says find a value. I thought that A was the A what we're looking. Find a value A so that the function, it is a piecewise function, is continuous. If I'm going to make this one up, and I'm going to make one up like it to show you how to think about it, it's not going to come out pretty. The process will be the same, so just stay with me. So it says, again, find a value A so that this function, which is piecewise, is continuous. This is the piecewise that's offered to you, something like this. Find the value of A. I think this is not A. I think
Is that x?
I think it's supposed to be X. Yeah.
Wait,
These are supposed to be X's here.
are we supposed to have two A's?
What do the A's mean?
That's our slope. It's like the end.
No, that's what you're supposed to find. You're supposed to find out what A has to be so that this function is continuous.
So that the function is.
Yeah, and you can't graph that because you don't know what A is.
I think the A on 5 is supposed to be X.
No, it isn't.
Okay.
So then it's a line.
Calm down.
What would make these two functions, oh, you're right, this is supposed to be X.
Okay. I was like, we can just make that so that is equal to -2 right there. And
You're right. Sorry about that.
So we both have to be at x equals -2. So that means you just put -2 into the top one, we know that it, so it'd be 10. So 2
It's A equals 2.
No, haha.
Oh, you're so cool.
We know it'd be 12.
Okay.
Then you have to set that bottom function equal to 12 while plugging the -2.
It's -2. Right.
Well, plugging the negative to it.
-2. A equals
oh yeah, I can see that. And
Okay,
then
so we've been
use
having some
algebra.
piecewise discussion here. Would you like to make it continuous, the discussion?
Yes.
All right, Axel, what's the first thing you would do? And just tell me the first thing.
plug in the -2 to the top function.
Why?
Because you
That
have
was a
to-
very leading question. Why?
Because you have to find the point, like, that they're gonna meet up, and you have to make them meet up at -2. So you have to make that function equal -2. If that makes sense.
No, it didn't.
Makes sense in my opinion.
Let me ask you this again. You said plug in -2 to the top function, and I said, why?
And
Why?
you said,
Which one we're talking about.
To find
We have
the
to find
y
the y
value of that
Yeah.
function, because this one has to have the same y value at 2 to be continuous.
So that's what I was trying to say, like.
He said it, but he just didn't say it.
No, he didn't really. He didn't really. He was talking about a point.
I understood.
I know, but nobody else did. Well, maybe they did, but I didn't fully appreciate the
so
message.
just plug -2 into both of them instead of equal to each other.
Yes,
So that's basically what you're doing, just
yeah.
in piecewise.
But
And-
this is
and-
just broken up.
Both
Yeah.
those stages, yeah.
They gotta both have the same
I
y.
didn't do anything.
Where one becomes the other, they have to have the same y value.
Yes.
That's the crux of this. So the question is, what is the y value when one becomes the other? That's why we plug this in here, to find out what's happening when you switch from the line to the parabola. So we take 2 minus 5 times -2, and we get 12. That means that this piece of the function has to have a y value y value of 12 when x is -2, when they switch. So the next thing is 4 minus a times -2 squared equals 12. That's what we're looking for. When does this function turn to be have a y value of -12 when its x value is -2? That will cause this one to end where this one starts, making it continuous. Do you understand? You following, Bunny? Yeah? Okay. So now we solve for a. The biggest mistake people make is they forget also becomes a -2, so that there's only one variable in this equation. I see people write a x squared all the time. I don't know how to solve that. Okay, so it's going to be subtract the 4 and you get -a times 4. That's what -2 squared is, equals 8. -a equals 2 by division, so a is -2, as Sam said. That's the value of a that makes this function continue. Did y'all understand how we approached it? Okay. X has to become 2 in both of these. It's just that you've got to solve the last one for a once you figure out what the y value is on the first one. Okay, so that's number 10. That's how you go about it. That's the work you showed to support it. In case you get it wrong, you better show your work. So let's say right here you said a was 2 and then you ended it. I better be able to tell where you came up with that. It will cost you very little if I can see it. If I can't see it, it'll cost you the whole thing. So show me your work. Okay, number 11. We gotta hurry up. We've still got 4 or 5 questions to go. So listen up. 11 says, sketch a possible graph for a function f where, and it gives you 1, 2, 3 stipulations you have to meet. Very much like the one on the quiz.
What was it like the super long one that you did?
No, it's like that. But there's only 3 things you have to do, not 8.
There's only 3 this time?
It's only 3. It says where f of a value exists, the limit as it approaches that is something, but it's not continuous there. You can handle
Last time it was
it. Oh,
4.
yeah. Yeah, this time it's 3. It's not very hard. Just make sure that all of the conditions are met and that no other condition happens because you just feel like it. You can't put any other discontinuities or anything in it. Some of you did that last week. You made things happen that were not stipulated in what it said, and it cost you.
Straight line.
Okay,
Straight line.
listen up. Shh. All lines are straight, by the way.
Okay.
Here we go. Horizontal is what you meant. Okay, number 12. Shh. Number 12 says, this one's super easy if you know how to answer it, and you won't be able to if you don't. I mean, it's easy. You're going to get it or you won't. And it says this. Use the concept of composite functions to explain why, and it gives you a function. It says, is a continuous one. I'm going to practically give this one away because it's not that important to your success in calculus, but I would like you to get this one right so that you understand. It has to do with that theorem 7 that we talked about when you compose 2 functions and you want to know if the composition is continuous. So if you have something like this, f of x equals the absolute value of x squared minus 2 over x minus 3. It says, give some explanation as to why this has to be continuous. And here's what you say. X squared minus 2 over x minus 3 is continuous because it's rational. And we already agreed that all rationals were continuous.
All rationals are confused.
They are,
Well, it doesn't.
Continuous on the domain.
which is assumed.
Get out of here.
This is continuous because it is rational. This is continuous. You don't even have to say why, but you can say if you want. It's continuous because
It is.
absolute values are continuous.
It is.
I think that's all we need is just it.
You really only have to say both of these. This is continuous, this is continuous. And you can stop right there. You can stop right there, would be fine, because we all agreed that it would be. Therefore, x squared minus 2 over x minus 3, absolute value is continuous by theorem 7. You have to make some reference to theorem 7, yes. Or if you don't call it theorem 7, then you say it's continuous by the composite function theorem.
Theorem 7. Sounds like.
So number 12, you'll either get it or you won't. There are 3 lines. Number 12, there are 3 lines. Fill them up with these kind of an explanation. Three more to go. We're going to make it. Number 13 says, find the average rate of change of the function over this interval. Many of you showed me excellent work, and you got almost all the credit, but your arithmetic stinks. You guys kill me sometimes.
It's dusty.
You might want to make sure your calculator says the same thing your brain does, because usually it's the other way around. Usually people make mistakes putting things in their calculator. You guys make mistakes figuring things in your head, or at least that's what I'm thinking is going on. I don't know. Could be that you don't know how to punch in your calculator. But consider this. If I give you this function, and it is something like negative x squared plus x cubed minus 4 over the interval from negative 2 to 1, 3. Find the average rate of change. Those are x's, you understand, right? It's not a point. So you need to find f of negative 2. That would be negative 2 squared plus negative 2 cubed minus 4. And right here's where people screw it up. They get the wrong y value. This is 4, but it's negative. This is negative 8. That's negative 16. Yeah? Okay. So you have a point over here that you're going to record. Negative 2, negative 16. Then you're going to find f of 3. And I want you to show me your work so I can see what you intended in case you do screw up a sign somewhere. It's negative 3 squared plus 3 to the third minus 4. That is 9, but it's negative. That's 27 minus 4. That's 18 minus 4, which is 14. So you also have the point 3, 14. Then you find the slope. 14 plus 16 over 3 plus 2.
3.
That was completely cool that that came out so nice. Yes.
Can we do like one of the sine ones where it has like the interval of 0 to 2 pi? Because I still don't know how to do those.
To find the average rate of change?
Yeah. With like
Where the interval is not from negative 2 to 3, but from 0 to 2 pi?
Yeah, it's like the sine ones.
0 to 2 pi or 0 to half?
We can come back to it if you like.
2 pi.
Because in the book it says like 1 plus sine x, so the interval of 0 to 2 pi.
Okay, we'll do that one in just a second, okay? Let me make sure I get through the whole thing, but this is how you would handle this. And I will tell you that they do give you a polynomial as a function, and they do give you nice whole numbers as your X range, okay? So be careful with your signs. Don't go too fast. Next one, number 14, we got 2 to go here. Number 14 says, for the function f of x equals, it is a polynomial. At the point, and it gives you a point, an x and a y value. It's a point, this time it's got parentheses around it. It says find, and there are 3 things. Find the slope of the curve, an equation for the tangent line, and an equation for the normal line. If the bell rings and we're still talking, you sit right there for a minute. You can just be late to your next class, I'm afraid. Hang on. So, if they give you a function such as this, f of x equals 2x squared plus 5 at the point -1, 6, we are to find the slope at that point of that curve. We are to find an equation of the tangent line at that point and an equation of the normal line at that point. What do we do first?
At that point?
At that point.
Well, that's not the point on that graph.
It has to be. It's a parabola. It contains every. Oh, it may not be that point. You're right. It has to contain the x. So what would it be? 1,
7.
2, 7. Yeah. Okay. Thanks. You're right.
Okay.
No, it's because he got it.
Okay. Shh. How do we begin to answer the first question?
What are we trying to?
Find the slope.
Find the slope at that point.
Oh, we want to
Do
get
our
a
slope
slope
generator.
Slope generator, which means we start with what?
2 of x plus
Use the right words.
The difference.
Difference
The limit.
The limit of the difference quotient.
As x approaches -1, but we'll get the generator. So it approaches as h approaches 0. Okay? So the limit as h approaches 0, that's supposed to be an arrow, of 2 times
x plus h squared plus 5 minus 2x squared plus 5.
Can I do that?
Or yeah.
Don't forget that it needs distributing
Yeah, same thing.
over h.
Over h. Bam.
So
So
can you guys foil that and distribute at the same time?
2x squared
2x
plus
squared
4xh plus 2h squared. That's what I said. Plus 5 plus 5. Minus 2x squared minus 5. So
Is anybody lost there? Because I did 2 things at once. We foiled that binomial and distributed it too.
okay, now cancel it.
What's the problem, Sonny?
Why is it a -5 instead of +5?
Because it was this before I distributed. You understand?
Okay, now get rid of the
All over
five
h.
and the 2x squared.
2x squared will add out.
Positive.
5s will add
And
out.
don't forget your limit as x approaches. Right.
Okay, hold on. I want to divide the h out first.
Forget the Z.
What do we get?
4x plus 2h.
2h.
And now don't forget
That's
h
right.
approaches 0.
Make sure you're writing this.
Yeah.
Equals
4x.
4x. So at what?
-1.
X equals -1. The slope is
-4.
-4. So the A part of the answer is,
-4.
well, M equals, but okay, -4. -4 would be fine. What do we have to do next?
Point slope form.
We have to write the equation of the tangent line. What do you need to write the equation of a line?
Slope intercept.
You need a point and a
Slope.
slope. Do we have those? We do. So now we write y equals, we can write y as y1 if you want, but I'm going to write y equals
-4
-4
times x plus 1 minus 7.
It's
plus 7.
It's plus 7 because it was minus over here. This is,
Rough.
yeah. so -4x minus 4 plus 7, -4x plus 3 is the tangent. And it goes over here in B.
And now we need the normal.
So you would write y equals -4x plus 3. Now we have to write the normal.
Okay, it's the same
How do we
thing.
begin writing the normal?
Just switch
Opposite with
the
slope.
Do we just switch this and that's
Yeah.
all?
Yeah.
No. We have to
This will change too.
switch up.
You gotta start up here again. y equals, what do I write?
1/4
1/4.
of x plus y plus
Plus 7.
Okay, so I get 1/4 x plus 1/4
plus 7
plus 7, which is 1/4
plus 29
x.
fourths. 29 fourths.
Yes.
Wow, that was a lot of math.
I can do
It's a lot of arithmetic.
Yeah.
Arithmetic is not math.
It's still math.
Arithmetic is silly. You should be able to do it without thinking very hard.
Yeah, Jake, how's that test going?
You all understand what's asked and how to accomplish it on this thing.
Yes.
Make sure you're showing me all of this in case you make a mistake in the slope generator or something.
Oh, really?
And if you get this one wrong, but you apply it correctly here, I'll give you credit for those lines. So show me your work, please. All right, Brooke?
Yeah, I just get confused when you do it, when you cancel out the H on the bottom.
The H divides, these all add out, you're aware of that?
Yeah.
If you divide H into this one, the H's will cancel and you end up with 4X.
H over
If you
H.
divide H into this one of the H's will cancel, but you'll have one left over.
So you can take it from both H's, from both.
H does the same.
Yes, you can put this monomial under both terms or multiple terms and handle, yeah. If this had ended up being, it had a plus H, then the H over that H is really one. And that's what Lottie screwed up the quiz. Okay, last problem. Last problem says, the equation for free fall at the surface of planet Quicksilver.
Oh,
At the planet what?
Quicksilver.
Quicksand.
That's my favorite.
Quicksand.
Me too, it's my favorite planet too. The equation, the equation for free fall at the surface of the planet Quicksilver is, and it will give it to you in this form. It'll say S equals, S is not speed. Get it out of your mind. S is position. V is speed. In physics, you gotta get used to that. So it will be an equation, something like this, and again, the author fails to use the negative. I think he's crazy. But on Quicksilver, we'll pretend that it is S equals, this is a really, really dense planet, 10.2 T squared. We'll pretend that's what it is. So the equation for free fall at the surface of the planet Quicksilver is S equals 10.2 T squared meters. So when you see this, don't panic. That is a unit, and it'll be really close on the heels of that T, and it looks like it's part of the equation. It stands for meters. Remember that. Don't get freaked out by that.
Need the following students to come to the office.
With T in seconds, it says that next.
Will Parker.
Is it negative? Is that?
It ought to be, but this author doesn't do that, so I'm giving it to you the way he does. Okay? Assume a rock is dropped from the top of a 400-meter cliff. 400 meters so that it has plenty of time to fall. There's nothing to do with the problem, really, except for that it's tall enough for it to fall a ways. Find the speed of the rock when T is 2.7.
2.7.
What do you do?
Slope generator.
Slope generator, plug 2.7 in, right? And that'll give you meters per second at that instant.
Yeah.
Do we need to do that? You want me to do it?
No, let's do it.
Let's do it.
It's fine.
Yeah.
Let's do it till the bell rings. Once the bell rings. 10.2
10.2
of T plus H squared
minus.
minus 10.2 T squared
Over H.
over H.
Alright.
Can you distribute again?
Yes.
Wait.
10.2 T squared plus
20.4
20.4
TH plus
10.2 H squared minus 10.2 T squared. Okay.
10.2 T squared cancels out with the negative.
Then you divide your H
H
out.
is canceled out.
20.4 T plus 10.2 H. Limit as H goes to 0.
20.4 T is our slope generator.
Plug your,
What was our value? 2.7. So
plug
we
it
that
out in your calculator because there's no way anyone can do that except for Miss J.
Miss J.
I'm not sure I can do that.
Point
I
zero.
could eventually.
It's 55.0.
And then, and the units?
0.08.
That's the speed. Oh, that's so good.
Make sure you include the units, that's important.
That's flying.
Oh, yeah.
That's the test. That's the test, and the test is tomorrow. If you need some help, get in here after school, I'll be here till 5.
Why do you take that quiz?
Wednesday.
The
When?
quiz from yesterday
What about it?
that I missed?
Yeah, when do you wanna do it?
Could I do it like 4th or 5th hour?
4th will be fine, 5th I'll be gone.
I'll try.
I might do the same.
I don't know, I got it, I got it, unless I thought about it, oh, but, yeah. I thought about it, and I was like, finally understood what you're saying. I was like-
I know, I'm like,
It's like-
Oh, forgot to end the video. Sorry, we're done. Have a great day, bye.